Good afternoon, everyone. Thank you for coming to the data center track at NANOG 65. Appreciate it. We're hoping today to do a couple of things. We want to talk about some current trends in data center, extend on some of the things we did in San Francisco, and where the industry is going, how it's likely to change in the future, and what kind of the new world of cloud and other services is demanding of the data center. And then, like we always do, we want to try to get a flavor for what the data center is in the region where the NANOG is located. And today we have three really good talks to give us a flavor for both data center and cloud in Canada. So to start us off, we have Josh Rabina, who is the co-president of Sentinel Data Centers, which he co-founded with Todd Aaron back in 2001. And they've actually gone through a couple of generations. They bought a bunch of post-meltdown data centers, rehabbed them, filled them with clients, and then decided to reset, sold those data centers, and have since built three entirely new state-of-the-art data centers, one in North Carolina, one in New Jersey, and one in New York. So Josh has been very focused on what the design is, what the future is, how you future-proof those assets moving forward. Josh will give a presentation first, and then he's going to be joined on a panel discussion by Todd Schreiber to his right, who is the data center strategy, architecture, and software director from Bloomberg LP. And Todd, we're very happy. We're always very happy when we have an end user, an enterprise here, so we thank you very much for coming. To Todd's right is Don Beatty, founder and CEO of DLB Associates. And Don is one of the leading strategists behind how cold your data center should be, or in many ways, how not cold your data center should be. So with that, and they'll be joined on their panel by Jason Von Gall, to my left. Jason is a serial entrepreneur. He's currently building and executing on the Root data center plan here in Montreal. Prior to that, he was the COO of Granite Networks, which was sold to Rogers in 2013. And prior to that, he was a principal of Planis Corporation, a data center design firm. So has a deep base in data center design. We're also going to have so Jason later will give a presentation. We're also going to have presentations from Michel Chartier on my left with Imtech Kelvin Imtech. And Michel has a deep history in design, and I'm sure he may have some things to chime in as well as we go through the panel discussion and questions. Michel is a certified tier designer, so we all talk about tiers sometimes openly. He actually does it, and does it formally. So if he does the consulting and says it's a tier 3 data center or a tier 4 data center or a tier 2, it actually means that. And then we're rounding out with Mark Pare from CloudOps on the left, who has some very fascinating statistics about the growth of cloud and services in Canada. So with that, I'm going to turn it over to Josh and let him kick off the presentation.
Thank you, Gabe. So we have a lot to cover, and we have a really great panel to get to. So I'd like to spend about 20 minutes or so talking about two quick topics that I think hopefully impact everyone, whether you're single rack, half rack, all the way up to a mega deployment, thousands of servers. The first really relates to resiliency planning. Are we overbuilt in what we're building for our applications? How robust does your data center really need to be? And the second, flip side of the coin, relates to capacity planning. So are we overbought? Are we buying more than we need to? And what are some strategies for analyzing that and figuring out how to remedy it if we are? So let's figure this out. Okay, so starting with the first piece, the low resiliency piece. So I don't know if anyone recognizes what's on the screen here. This is one of my favorite examples of a low resiliency product. So this is something that's come to be called a bit barn, so to speak. It's based in Iceland, and it's been built by a Bitcoiner who, as you might guess, took an old farm building and retrofitted it to hold a bunch of servers. Plywood on the outside, corrugated sheet metal, put some cupolas on the roof, basically popped a big hole in the side for the wind to blow in for cooling. No UPS, no generator. Next page is a little picture of the inside here. Little cheesecloth as a filter on the outside, homemade racks, some unistruts, some twist ties and tie wraps, and voila, you've got a fairly high density functional data center. And by no means, by the way, is this a condemnation. This is an amazing solution. High praise, does what they need to, and it gets them the lowest possible cost per kilowatt that they can get down to produce their Bitcoins. Reliability, doesn't have to necessarily matter all that much. Low resiliency designs can also look very similar to what everyone's used to seeing when they walk into a data center. So raised floor, doesn't necessarily have to look any different. Same kind of rack deployments, may just have upstream infrastructure that is either absent, so no generators, no UPS, or winnowed down to very basic N-type deployment. All of this is born from the basic idea that you don't necessarily always have to build to the highest common denominator, that to the extent that you're nimble enough from a software and application perspective to segregate loads, that it may very well make sense to put your very high resiliency, high uptime required loads into expensive product, and put the stuff that can stomach an outage here and there into less expensive product. So we've seen this product being born over the last few years as folks begin to virtualize and begin to spread their loads. And as the product forms in the marketplace, it always starts with a fairly blunt definition. We see folks show up and they say, just give me basic tier 1, or give me, basic N, or single path. And, there's a few different names people use. We think, as this product matures and gets more attention paid to it, a more fundamental question will start to be asked and summarized basically by this phrase, which is, does N always equal N? For this low resiliency stuff, is one guy's N always the same as another guy's N? What differentiates one solution from the next? How do you define quality? Oh, it sounds a little oxymoronic, but there's a difference between high quality and low quality, even within the space where we're only targeting a reduced resiliency level. So as we think about how you compare ends, and this goes for tier 3, tier 4, as well as tier 1, tier 2, but it's just talked about less for tier 1, tier 2. There's two questions you always have to ask with respect to outages and resiliency. The first question is, how often? What's my mean time between failure? How often is it going to fail? The other question, which I would argue is equally, if not as important, is for how long. When it fails, especially in a single N lineup, single resiliency system, how long is it out for? I think the second question we have found as people show up to shop for this space is something that people are much less capable of talking about and thinking about. It's easy to think about how a well-built system, how long is it going to run for, how often is it going to fail. There's a lot more complexity around how long it's out once it's failed, and that how long question is something that I think is going to increasingly determine quality differentials between high resiliency and between high quality and low quality, low resiliency products. So why does the second question matter so much? And it's not important necessarily to get in the weeds on the numbers, but suffice it to say, if your mean time to restore after a failure of any sort is extremely high, if it's weeks or months, almost doesn't matter that much how long your mean time between failure is. You're probably being out at any given time during the life of your occupancy in a data center, whether you built it yourself or you're releasing it or it's colo or whatever it is going to be non-trivial. It's going to be higher than a percentage point. If you can somehow optimize a solution such that your mean time to restore is just a few hours for any given component, again, almost doesn't matter how long your mean time between failures, if it's 2 years or 7 years, you're always below 0.03% of the time, just to take the example furthest to the left there, of your probability of being out at any given time. So hugely important stuff to think about. Would you rather buy a data center that was out once a year for 15 minutes, or was out once every 3 years for 2 weeks? It's a question that is very, very much applicable as you're shopping for this stuff, and very high quality solutions could fit both bills very equally, and it's something that you really have to dig into. So to help develop the intuition around how much mean time to restore can vary, just 3 quick pictures here. The photo on the left is a breaker failing. We've all lived with it, the same breaker systems that we all have in our houses and apartments. You pop a breaker, it fails, you have a spare on site, you change it in 5 minutes. Photo in the middle is a picture of a centrifugal chiller being maintained, and we've lived through that, and that can be a very, very painful process. It can be up to a month. There can be a refrigerant leak. You may not find it the first time. You got to reopen it. You got to these things have to be rebuilt every 10 years, etc. So if you're building an end system with one of those in the lineup, you got to be cognizant of the fact that you could be out for months on end. Picture on the right, which was a really cool video of a transformer blowing up, that unfortunately I don't have the MP3 behind it in this presentation, but there are complete disaster scenarios in every data center, in every type of lineup, where you can be out for 6 months on end. So you get a high voltage breaker or transformer fail. What you would have seen on that video is basically a big mushroom cloud with the whole switchyard going up into smoke. Obviously not a quick recovery. So the short answer is yes, something to be very, very concerned about as you're planning data center space. Tools available. What tools do we have available as we're planning this low resiliency product, and as we're trying to provision for these customers? Obviously, there's a basic set of tools that we have to use as we build these solutions. And really the right way to think about all these solutions is at a granular level. It's not just the system as a whole, but it's every piece of the system. You're only as good as your weakest link, starting at the utility all the way down through to the last breaker and the last perforated tile in your cooling system. So obviously equipment selection matters. There's trade-offs in every piece of equipment selection. You may buy big stuff that gets your cost per kilowatt down to very, very low, but it may not be hot swappable. Every piece of the system has a trade-off you can make to that degree, to that effect, as you spec and purchase facilities. Spare parts on site is obvious. Appropriate staffing on site and operating culture. This is a huge one. So operating culture, are you in a commercial office building when it's kind of I'll get to it when I get to it mentality? Are you in a data center provider who's used to providing tier 3 product and is has a 2N system, and there's not a lot of urgency when something fails in a 2N system because there's another N sitting for it? Are they built to respond in 10 minutes if a breaker pops, or to have a 4-hour response contract with their UPS vendor if you blow your UPS system? Culture is massive in this piece of the space. Short duration vendor response speaks for itself. Bypass the utility. You often, for the cost of a simple breaker and a feeder, you can bypass something like a UPS system that takes your mean time to restore from a couple days or weeks down to a few minutes to get you back onto utility. Same thing for taps, for rentals and roll-ups, etc. And then the last piece, selective redundancy. Often, and it's somewhat a bias as people have been trained to think by the Uptime Institute, of either it's everything's resilient or nothing. I'm either tier 3 and I have N+1 on everything and I'm fully concurrently maintainable, or I have, I'm tier 1 and I have a single lineup. There's no law or religion that says you have to have all or nothing. If something has a high mean time to repair, let's say you want a centrifugal chiller because it can get your PUE down to the lowest level in the particular geography that you're in, and it happens to be a high mean time to repair item, buy 2 and keep everything else at 1 because you have spare parts on site. There's nothing that says you can't do things like that as we start to think in this world. So to that point, the industry doesn't, in my opinion, have the vocabulary really to speak about this stuff yet. Both of these solutions shown here are tier 1 solutions. If you showed up and just asked for a tier 1 solution, you very well might get the solution on the left. Both are N solutions. The only difference between the first and the second is the guy who built the second spent $10,000 on a 12-inch tap in their supply and return piping, and has the ability to roll up a rental. And that takes the mean time to restore from weeks and months to less than a day. And for the same price, you can get both, and that matters less in tier 3, which we're all used to buying. That matters a ton in tier 1. So quick takeaways from this section. Obviously, low resiliency designs are becoming part of the landscape. Don't rely on existing vocabulary. Guide your design based on specific tolerances and really get into the weeds. There are always low-cost ways to get your restore time up that can dramatically impact performance. And then push your facilities teams and providers to think holistically. And the last one, which we are starting to do and we're starting to see, the best way to keep everyone honest in this space is to begin to ask for SLAs around restoration time. So if you're looking for a low resiliency product, and rightly so, your provider or your engineer, whoever's building it for you, says, we're not willing to stand behind 5 nines or 100% uptime on this product because if something fails, we're out of luck. You can build SLAs around time to restore, and time to restore of a 24-hour SLA on time to restore is a hugely different product than a 30-day time to restore. So food for thought. Quickly moving on so we can get to the panel here. A few minutes on the next problem, which is the overbought problem related to stranded density. So this is a chart back in 2007 that made the rounds into every trade show and every publication in our very niche, geeky data center space. Everyone saw that density had been marching up steadily from 1992. Everyone had experienced it, and it was going to basically continue forever. And everyone basically battened down the hatches and started building data centers that could house rows and rows of pizza ovens. A whole slew of vendors popped up just to build products around cooling those pizza ovens, etc. Whether it materialized or not is a subject of some debate. In some places in this stack and for user types it did, in others it did not. This is some data on from HP, and various things intervene, new chip technologies, better control of idling fan loads, new storage technologies, etc. Many people got caught by surprise for this. So for example, the guys who had geared up to be selling tons of in-row and in-rack cooling and water to rear door heat exchangers and thought that was going to be ubiquitous, and the days of the 5 and under kilowatt rack were going to go away, had massive sales disappointments. And it didn't, with the exception of, probably many in this room who may use high density loads, it did not become as ubiquitous as had been advertised. And the point is not that loads are going up or down or staying sideways. The point is we live in a space that's defined by uncertainty. Uncertainty, as an astute woman for Gartner pointed out, is kind of built into the DNA of how the data center space operates. And what she pointed out was, you have these natural ebbs and flows wherein the deployment of new technology makes things more efficient. People take the time and eventually figure out how to use that technology, start consuming it again, and you get this sort of sawtooth line that she was saying tends towards up, which is probably correct. But where you are on that line at any given point in time, in a world where to build efficiently, data centers are building long-lived assets. If you're not using a data center for 20 plus years, you're not getting all of the value out of that data center. And given that IT refresh cycles are 3 to 5 years, the space is defined by uncertainty, and uncertainty can wreak havoc, as I'm sure many of us in this room have experienced, on business outcomes. So how do you deal with this uncertainty? The first question you ask yourself is, how would you deal with a world in which everything was 100% certain? If I knew the next 10 years exactly what my loads are going to be, where would I build to my optimal density? And again, not getting into the weeds because it's a whole nother discussion. You can model what the cheapest possible cost per kilowatt, cost is across all different kilowatt per rack densities, and you can come to a conclusion as to what the lowest cost per megawatt is. And suffice it to say, it's, depending on who you believe, and it's a complicated question, which includes things like people and software and others that have to go in the equation, somewhere around 5 or north, and could be considerably north, most people agree is kind of an optimal price point to build to a data center at. So do you build everything to that price point? That's the big but, so to speak. And the answer is probably not, because of stranded density. If you had to ask me what I think the biggest cost to our industry as a whole, the data center industry, has been over the last 2 decades, I would say more so than real estate, rent, power, cooling, PUE, stranded capacity has been the biggest sink of capital in the space, would be my strong instinct. Folks building a 1 megawatt data center, putting in the capital in to build it, run it, etc. If you end up only using 600 kilowatts of that, 30% of your costs were basically frittered away and never recovered within the depreciation cycle. So this chart, I believe, is extremely important in helping instruct how to make decisions around this stuff. And what this basically says is if you build a 5 kilowatt per cabinet data center, which is your design density, if your density materializes exactly as you forecast it to, your effective cost is about $8 or $9 per watt to build a tier 2 data center, and call it twice that to build a tier 4 data center. If your density materializes above forecast, i.e. you strand a little bit of space, but you consume all your power, off to the right side of the curve there's almost no cost penalty. You're inching up marginally, meaning that space is basically cheap. But if you end up at 2 kilowatts a rack, as you can see from the left side of the curve, there's a massive cost penalty. You're almost at 2 or 3x your cost per effective kilowatt of deployment. And so what this is basically saying is, again, when refresh cycles are short and asset lives are long, build more space. Build more space as an insurance policy to cover yourself. Or said differently, build lower density. So if you built this, instead of that, you buy yourself a little bit more breathing room. So you're building a 4 instead of 6. If you run out of space, not the end of the world. If you run out of power, not the end of the world. But if you run out of space before you run out of power, very, very expensive. As an aside for the NANOG guys in the room, one thing we see over and over and over again when guys build for 24-inch wide cabinets and their network guys convince them to deploy 30-inch wide cabinets, it crushes the TCO of the space, because all of a sudden you take a room that's 5 kilowatts a rack and you turn it into an 8 kilowatt a rack room, and no one can use the power, and that always, unfortunately, is the network guy that makes that happen. So how do you buy in this context of uncertainty? Last couple slides quickly. First off, we see a mistake made over and over again. Don't use a static forecast. That's where we see all these mistakes made. The world has, historically, when back in the days before things started virtualizing and all this uncertainty showed up, my IT load was growing at 5% a year, so I know I have 600 kilowatts. I know it's going to keep growing, and that I'm going to build one blue line forecast, and I'm going to buy everything around that one forecast. The right way to do it is to model uncertainty points. I know 3 years out, I'm not going to hit a refresh cycle. Things might change. I could go red. I could go green. I might stay blue. Just understanding that first and foremost is going to massively impact the way you buy and consume space. Once you figure that out, then you come up with strategies as how to protect yourself, to buy insurance policies, so to speak, to the extent your blue and your green lines don't materialize. So day one, so for example, if you're building it yourself, you can tell your engineer, look, I know I need the red stuff, but put in taps and some valves and some floor stands and some space in the yard to get me to the blue and eventually to the green if I end up being to get there. If you're buying from a colo company, find a guy that appreciates this value proposition, that understands for the most part that space is cheap and that power is expensive, and can structure optionality for you in a contract that can cover you to the extent things, you buy for the minimum and you cover yourself with options for the upside. Likewise, on the space front, if you have the ability to, and space is inexpensive, which it is in most markets relative to power, lease more space, take more space. That's one of the key lessons learned. All right, so final takeaways. Again, uncertainty regarding load growth remains high, always will. Stranded power can dominate everything if you don't pay close attention to it. Model power demand sensitivities in detail, err on the side of lower density. Seek providers that can provide optionality to the extent that it's available. And last but not least, don't let the NANOG guys buy your cabinets. And that's the quick presentation. So with that, we had, as Gabe introduced, a great bunch of panelists that we're going to talk on some of these data center issues. I think have been introduced already, but figured we'd start with maybe Todd here from Bloomberg, and I think the perspectives we have are really Todd, who represents enterprise. He's been through wars with Bloomberg, a very, very data intensive company, has helped them navigate a lot of these issues. We have Don Beatty, who I consider one of the Mount Rushmore type engineers in the data center space. He founded the TC 9.9 committee and has done a lot of advisory work for the web scale, major deployment type players. And we had Jason also, who is the local flavor here and also represents a colo business. So we got a good coverage on a lot of these issues. So maybe starting with kind of the resiliency question. I know for Bloomberg, data center is really the lifeblood of the business. Todd, how do you guys think about kind of the equation of value versus resiliency?
Well, with Bloomberg, we have very expensive products. We have customers who we have to take care of at all costs. So resiliency is by far a higher criteria than the actual expense to get it. So it's, we'll spend the money to protect our customers and improve the resiliency.
And how would it culturally within the organization, where would you get resistance, or who would the resistance come from if you were to go and tell someone, look, I could save you 40% of your capital expense?
That's a good question, because it's something that we would like to accommodate lower tiering in the data center. We recognize that we could save money and potentially lower costs if we could get customers, our internal customers, our application owners, to agree to move to a lower tiered data center infrastructure. But we can't find anyone who's willing to step up to the bar and say, my customers aren't as important for my application as someone else's. Yeah. So it's very difficult to get buy-in on that.
And we've seen that a lot. Don, do you have any words of wisdom on this, Todd? You deal with a broader customer set than obviously the financials. Are you seeing receptivity to this? Kind of
so I believe if we look at it at the broader domain, then it's all about the workload. And different companies, internet companies, financial companies, they all have a different workload profile. And workloads really change over time, applications and so forth. And therefore, what's the data center going to look like in 5 years or 10 years as relates to tiering? So for those where they think that the workload is going to vary over time, then they tend to focus more on variable tiering. And those that are more in a constant kind of constant type of workload, like the low resilience type and critical trading kind of things, they tend to stick with what's really most important for them, like what Todd has said.
And is there a certain scale you think where asking questions like this begins to matter more? Or have you seen, is this something that's only accessible in your mind to the web scale companies, or do you,
So some people would say that at a certain scale, there's a data center in a rack, that the densities have gotten up and you have edge computing and all those sorts of things. So as you get that really heavy density into a rack, you can easily have 4 racks in a data center and they'd be different tiers.
Right.
So it could actually be all over the place.
Yeah, interesting. And Jason, I don't know if you've got 2 cents on what you see typically in the colo space in terms of what are people demanding in terms of SLAs, and is there any discussion of this stuff yet?
Yeah, yeah, absolutely. And I think it really, what people are asking for in terms of SLAs really varies from client to client and, varies widely, especially from retail to sort of wholesale customers. The more mature and sophisticated customers will maybe ask for things like variable tiering, or they'll be more rigid on their SLA requirements. I think one thing, that we've kind of seen, or some of the design concepts that we've played with is that there's a way, an affordable way to move sort of from a tier 2 topology to a tier 3, and I think you spoke about it a little bit in your presentation with the MTTR and some of those failures. You have to take that into consideration on the operation side, how to plan against that. And so when you move to this sort of concurrently maintainable design, you can kind of see some of the operational expenses really get compressed in. So when you're spending more on CapEx, you can sort of offset a little bit on the OpEx side in terms of how you're maintaining your systems, when you're maintaining them. So you can do this variable tiering concept, which may sometimes introduce operational challenges, and who do I have on 2N power, when can I do my maintenance, whereas if you kind of keep it flat across the board, you can have that sort of operational flexibility a little bit more.
Yeah.
So that's some of the stuff that we're seeing.
Great. Maybe Don, this is a good time to talk about TC 9.9 for 2 minutes. Just I don't know, for those in the room that don't know it, Don's done a lot of work around raising temperatures in the data center, and maybe you can give the quick state of the state as to how the adoption levels are, and where all of this has to do with resiliency at the end of the day, I guess.
I think you're saying that we were a flop. So ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, has a committee, TC 9.9. It's a technical committee, and all the IT manufacturers are on it, and that's how we created the standards whereby we can raise the temperature up to much higher temperatures and still be reliable. So the recommended range is now 18 to 27 degrees C, as an example, and does not impact warranties or any of those sorts of things. So really a big difference. But just like what's going on in the rest of the world, where software is eating hardware, you could argue software is eating ASHRAE. That fundamentally ASHRAE right now is struggling with how to integrate into that whole package enough software understanding to know what's really going on. And that's kind of the real struggle.
What's going on in the sense of actually being able to measure and track and perform, set benchmarks and that?
So for example, at the server end now, there'll be 30 to 150 sensors on a server and variable flow. And there's up to 20 states, system states, performance states, throttling back, and so you have this moving target. And so you could have energy conservation going on in the data center at the data center cooling end that's offset by the fans ramping up at the server end.
Right.
They got these fancy algorithms and all this stuff, and so to integrate that really involves a lot of software.
Yeah. So
Same thing on the network side.
So you may think you're saving money on your cooling bill, which you are, but you may be feeding it right back into the slot machine on the server fans. Todd, what's Bloomberg's stance these days on temperature in the data center?
We've progressed, from a very, let's say, an older data center to, a modern data center. We just opened a year ago, and the modern data center we're now running at about 75.5 degrees is the temperature in the data center, versus the older data center, which is still in the 50 degrees. These are all Fahrenheit. I don't have Celsius. Sorry.
Right. Yeah. Right, the meat locker.
Yeah, the meat locker. So it went from, you have to put a jacket on and a hat to work in one data center to you're actually, rolling your sleeves up in our modern data center, if you will, with the intent to save on the cooling and so forth. And as Don suggests, we're seeing some of these scenarios where the servers are ramping up fan speeds to counteract what they may see going on in their local environment.
Interesting. And Jason, is there receptivity in the colo space to higher temperatures, or are people scared when you walk into a room?
I think, again, it ties into sort of the customer's sort of sophistication. Right. What we typically do is when we push back, and thank you for bumping up our ASHRAE standard a few years back, we really push at that as sort of, we're doing this in accordance with industry standards, and, if ASHRAE is saying this is the right way to operate the data center, let's do what they're asking. Yeah. And so most customers have been fairly receptive to that.